All right, if we're going to use exponents to simplify factors in a term, um, we want to know what it means to simplify. So first of all, factors in a term are simplified when. So we have three things we're looking for. Each factor occurs only once, no parentheses or outside powers, and no negative or zero exponents. So this is going to give rise to kind of a general strategy, and you'll see this happen out here. One of the things that we'll do first, of course, any zero powered factors we're going to convert to one, but applying all outside factors, but outside powers, excuse me, and then converting all negative powers to all negative powered factors to positive powered factors, and then canceling or multiply repeated factors. So if we look at a couple of questions or a couple of examples here, these first two examples, we notice we have an outside power. So we're going to apply that power by multiplying exponents. So this would be equal to x to the negative 6. And then any negative exponents we're going to convert to a positive. So this would be equal to 1 over x to the 6th. So this would be the simplified version. So no negative exponents, no outside powers. For b, again, we have this outside power. We want to apply that power to every factor. So we would have a negative 3 to the negative 2 power. We'd have x to the negative 2 times negative 2, or x to the positive 4th power. And then we'd have y to the negative 2 power. So convert, once we have this, now we can convert all of our negative exponents to positive. So this negative 2 factor of negative 3 would end up in the denominator as a factor of negative 3 squared. X to the 4th would stay in the numerator, and y to the negative 2 would move to the denominator. So the last thing I'm going to do is just evaluate negative 3 squared. So I'd end up with x to the 4th over positive 9y squared. All right, the next two examples, again, we want to find ways to simplify. So there is no outside powers here. So the first thing we're going to do is convert. And again, you can do this different ways, but we're going to take and rewrite each of our factors to positive. So a to the negative 4 would go to the denominator as a to the 4th. A to the negative 5 in the numerator would go to the denominator as a to the 5th. And then a to the negative 3 in the denominator would move to the numerator. Now all my factors have positive exponents, and I can start multiplying and canceling. So we'd have a cubed, the denominator of a to the 4th times a to the 5th, so this would be a to the 9th. And then I can cancel all three of the factors in the numerator, leaving a 1, and then 3 factors in the denominator. So this would leave a 1 over a to the 6th. All right, so for D then, I do have this outside power. So I'm going to apply that outside power to every factor on the inside. So that would be a factor of 5 raised to the 2nd power. We'd have a factor of a, and cubed to the 2nd power would be a to the 6th power, multiplying those exponents. And then b in the denominator would be, a factor of b would be negative 6 times 2, or negative 12. So again, we have a negative exponent. So the next thing I'm going to do is just choose to move this negative exponent to the numerator. So I would end up with 5 squared, which is 25, a to the 6th, and then b to the 12, negative 12 would move up to the numerator as b to the positive 12th. All right, so the last two expressions are actually the same, but I wanted to go over how you can simplify two different ways. So if we stick with our strategy, we have this outside exponent. So if we apply that first to every factor on the inside by multiplying exponents, we'll end up with, here's c to the negative 2. So the c to the negative 2 would be c to the negative 6th power. D squared would be d to the 2 times 3, or 6th power. c to the fourth in the denominator would be a denominator c to the 4 times 3 or 12. And then finally d to the negative 3, if I apply the power of 3, would give me d to the negative 9. So again, every factor, we multiplied exponents. We have no more outside powers, so now we're just going to convert all of our negative exponent factors to positive. So what would happen is c to the negative 6 would go to the denominator as c to the 6th. D to the negative 9 would go to the numerator as d to the 9th. D to the 6th would stay in the numerator because it's positive exponent. And then c to the 12th would stay in the denominator because it's positive. So it looked like we might have some canceling, but in this case, it's just combining the factors on top. D to the 9th and d to the 6th would be d to the 15th over, and then 6 and 12 is 18, so this would be c to the 18th. So again, we could apply that outside power first. But the second way we could do this is by looking inside the fractional factor inside, and instead simplifying inside first. So if we simplify inside first, then we can convert all of the negative exponents to positive. So c to the negative 2 would be in the denominator c squared. D squared would stay on top. C to the 4th would stay on the bottom. And d to the negative 3 would go to the numerator as d cubed. Again, simplifying inside, we can combine those factors. D cubed and d squared times d cubed would just be d to the 5th power, adding up those factors, and then in the denominator be c to the 6th. So once we have the inside simplified, now let's apply the outside power, and multiplying exponents, we'd have d to the 15th over c to the 18th. So again, there's more than one way to simplify factors, integer factors in a term.